factor cubics. So what's nice is that what can you do? You can cancel all three of them. Are there any vertical asymptotes? No, because all of the terms in the denominator go away. All of the terms in the denominator go away. So because you canceled 3 times, what do you have 3 of? 3 holes. So what's left? F of x is equal to 4. What does this look like when you fill in all the holes? F of x equals 4. That's what it looks like. What happens 3 times? There are 3 holes. There are 3 holes right there. Now how do you find? Well, you know what the y value is because what's the entire equation? Y equals 4. And what are the 3 holes? 2, 4, and 6. I like how this is done because you can see where the holes are by exaggerating the size. Considering how big is a single point? Very, 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 very small. Yes, Connor. This one's already at least partially factored, right? So what happened first here in the green? What happened first? A little bit more factoring? A little bit more factoring? When you see this, what should you think right there? When you see that, what should you think? That's the difference of? Yeah, difference of squares. Difference of squares. Nice. A squared minus b squared is equal to a plus b times a minus, not c, b. So here's that nicely factored form. The only thing that changed was canceling the 2 from the 8 and 4. So you're left with 2 times x minus 5 and x plus 4, x minus 4. Are there any holes? No. Why not?
Because nothing canceled.
Nothing canceled. So you have 2 what? We have 2 what? Vertical asymptotes at x equals 4 and x equals negative 4. So you could go over here and you see those 2 dotted lines? Where are those 2 asymptotes? Those 2 asymptotes are right here in the yellow. Can you see that yellow? Does that come up at all?
Yeah.
Those are where the asymptotes are. So you can put those dotted lines in immediately. What's the domain going to be? It's not stated here, but can someone tell me what the domain is? X such that x negative 4 or 4.
Let's say 4 on the left.
I need more.
Top left.
Top left. Yes, that's a 4 right there. Yes, that's you're talking about this right here?
Yeah.
That's a 4. Yep. Yeah, so 8 over 4 is just 2 over 1. That's why 8 over 4 turns into 2. Okay, so we have vertical asymptotes. So, this figures out the y-intercept. That's the y-intercept right there. The y-intercept is when what is equal to 0? When x is equal to, when 0 equals 0, that's fine. So what do you plug in for 0? You plug it in wherever x appears. So plug in 0 for all of the x's, and what do you end up with? 5/8. So that tells you the y-intercept, where it crosses the what axis? The y-axis. So you go over here, that's this point right here. 0, 5/8. So now what do you do? What's the rest here? Oh, the end behavior. So you look at the limit as x goes to what? The factored form of the numerator is. So take a guess. Take a wild guess. X what? Plus 5 and? That seems good. What's the bottom become?
X minus 3, x plus 2.
Yeah, x plus 2. So what do we find next? Careful, what do we find next?
Domain.
The what? No, don't cancel yet. Domain. Can someone who hasn't spoken yet tell me what the domain is? It's x such that x can't be what 2 numbers? 3 and negative 2. Now what can we do? We could, but I like to do something first before that. Now what can you do?
Cancel.
Let's cancel so we can get rid of this and this. Now, what is this equal to? It's equal to x plus 5 over x plus 2. We've canceled, so what does that mean there's one of if we canceled one thing? There's a hole. What's the x value of that hole? 3. How do you find the y value? Plug it into what's left. Can someone tell me what's left? 4/3, really?
No, 4/5.
Hold on, think about it in your head first. There you go, on third guess. What is it, 8 over what?
8 over 5.
It's 8 over 5. Do you see why it's 8 over 5? We good with that? Okay, so we have a hole. What's the next thing I could list out? What's the next thing I could list out? What's another property? Vertical asymptote. Connor, can you tell me what the vertical asymptote is?
X equals -2.
Yes, exactly. Hey, if we got the vertical asymptote, what could we list? What could we list if the horizontal asymptote? Can you tell me what the horizontal asymptote is?
We plug -2 for x.
Nope, you don't need to. Look at the degree of the top. What is it?
1.
No. What's the degree of the top? Oh, sorry, excuse me. That's a fair answer. Of the simplified one, this still works. Oh, it is 1. What's the degree at the bottom? 1. The degree is the same. So you just look at the what? If the degree is the same, what do you look at? The leading coefficient, which is both what? What's 1 over 1? So what's the horizontal asymptote? Y equals 1. What could we find next? What's another thing we could find? What? What could we find next, Nick? Bingo. Which one do you want to do first?
Do Y first.
Let's, the y-intercept first? So the y-intercept is when what is true? So let's plug in x equals 0 right there, and what do you get?
5 over 2.
Correct. So if we have the y-intercept, what do we find next? What's next?
X.
Yeah. The x-intercept is just y equals 0. So if 0 is equal to x plus 5 over x plus 2, what does x have to be? -5. So it's going to be -5 comma 0. We have asymptotes, we have intercepts, we have vertical asymptote, horizontal asymptote, we have a whole. I want you by yourself right now with all this information, draw me a pretty graph. This? How's that? How do you know it goes up and down? How do you know it goes up here and down there?
Both powers are on.
Well, there's only one down here, right? The power of x plus 2 is 1, so you know it has to go up and down. And what do these points, because this one's higher than this one, suggest? It's going to go up. It's going to go up. Another thing I tested, I don't know if you saw it over here, I asked the question, does this cross the horizontal asymptote? So there's a horizontal asymptote here. What is it? Y equals what? 1 is the horizontal asymptote. I asked the question, does this function cross it? So what did I do? I set the function equal to 1 and I ended up with what? 2 equals 5. Is that true? No. So what does that mean about my original statement? It's not true. It can't be solved. So does this cross the horizontal asymptote? No. Did it cross on the other one? Yeah. It is possible sometimes. It is possible sometimes to cross horizontal or oblique asymptotes, but we don't talk about those yet. We don't talk about those yet. So here are some added ones you can work on as extra practice. What's the only difference here? What's the only difference between this question and the one I just asked you? Yeah. It's slightly harder to factor. The harder part to factor is going to be this right here. You are going to have to see how much you remember of factoring things that look like that. I'm sure we will talk about this. Factoring is something that you don't just all of a sudden can do all of. It's practice, 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 and then more practice. Although, anybody want to take a guess how you factor that one right there? Yeah, what method do you use? Yeah, you love grouping. Grouping doesn't always work, but when it does, super helpful. What can we take out of the first two terms here? X squared is x plus what? 3? And what can you take out of the other two?
6.
I think -16. And what do you end up with? Oh, x squared minus 16 times x plus 3, x plus, oh, does it factor nicely?
Yeah.
Yes. Is that always going to work out that nicely with cubics?
No.
No. Yes, it will. Yes, it will. We'll force it. We'll force it. It doesn't. It doesn't. Sorry. So your homework is listed. Have a good evening, everybody.